Welcome to this video on debugging 5G networks using Mobisync 5G Logger, a UE side logging tool from Make My Technology. The Mobisync 5G Logger allows you to see what the user equipment sees, live, decoded, and in Wireshark. This video will be presented by Nitin Jain, an independent consultant with extensive experience in wireless signal processing and cellular systems. The agenda includes the importance of tools, an introduction to the closed 5G black box problem, an overview of the Mobisync 5G Logger, debugging scenarios, a live demo, and information on trial licenses. We begin with Section 1, the importance of tools in debugging 5G networks. Choosing the right tool is essential for working smarter, not harder. The right tools save time, effort, reduce stress, and lead to better results, as illustrated in this image. We will now dive into the introduction, which is the second item on our contents list. Our introduction uses a murder mystery analogy to represent the complexities of debugging 5G networks. The missing common piece in this puzzle is the key to solving the mystery, and we will reveal it layer by layer. The missing common piece is the collection of forensics data, also known as logging tools. The Mobisync 5G Logger is a tool designed to collect logs from the COTS mobile side to help solve 5G GNB, 5G UE, and feature-related issues. The closed system challenge highlights the problem of 5G networks operating as black boxes, missing UE side visibility. Issues include proprietary barriers, asymmetric insight, and guesswork debugging. UE logs provide true stability through end-to-end correlated forensics, offering UE capability validation, LAYER1 truth, protocol clarity, and a full-stack view. Moving on to Section 02, the introduction. Mobisync 5G Logger allows you to instantly see what your 5G UE sees. It provides live RRC, NAS, MAC, RLC, PDCP, and L1 logs, works with COTS phones, and only requires a simple plug and click to see live 5G data in Wireshark. Mobisync 5G Logger is a lightweight, cross-platform tool providing live UE side protocol forensics without the need for dongles or SDKs. It offers plug and decode functionality, live logs across all layers, and zero setup friction with a single executable on Linux or Windows. The Mobisync 5G Logger provides real-time visibility, allowing you to view live RRC, NAS, MAC, RLC, PDCP, and Layer 1 logs directly in Wireshark. This is perfect for GNB bring-up, throughput optimization, or diagnosing failures with zero fuss. The setup overview is simple. A 5G network connects to a 5G COTS UE via the 5GNR air interface. A single USB cable connects the UE side world to your host machine, running the Mobisync 5G Logger and Wireshark for live capture. This general use case setup involves the host machine running the Mobisync 5G Logger and Wireshark, connected by a USB cable to a COTS smartphone. The smartphone connects to the 5G network via the 5GNR air interface. The next scene, number 16, is a transition slide. We will now move on to Section 03, Mobisync 5G Overview. Mobisync 5G is designed to overcome the limitations of the old way, which involved heavy, expensive, and vendor-locked toolchains. With Mobisync, you get a plug-and-see experience with decoded 5G messages live in Wireshark, no vendor lock-in, cross-platform support, and an affordable, instant solution. Simplicity drives innovation with a developer-first philosophy. Traditional tools are cumbersome, requiring complex setups for offline decoding. Mobisync offers instant, live results with no dongles or vendor lock-ins. Simply plug in your phone, click Start Logging, and view the decoded messages instantly in Wireshark. It supports a broad range of devices like OnePlus, Quectel, MI Poco, and Samsung. Mobisync advantages at a glance include true live Wireshark decoding without export or conversion, compatibility with COTS phones without custom firmware or routing for many models, and a lightweight single executable that runs anywhere. It provides protocol transparency, cross-platform freedom, affordability, and custom extensibility. To summarize the advantages, Mobisync 5G Logger offers true live Wireshark decoding for faster issue resolution. It works with COTS phones, is a lightweight single executable, and provides protocol transparency. It is cross-platform, affordable, developer-friendly, offers instant debug feedback, and is custom extensible for future-proofing. Mobisync is perfect for every 5G development phase, from network bring-up to field diagnostics, providing a consistent one-cable workflow. It covers initial bring-up, exploration and tuning, development and testing, and field diagnostics, ensuring you stop guessing and start seeing, iterating confidently. Mobisync offers extensive protocol coverage, decoding every layer of the UE stack live in Wireshark. Feature highlights include live and offline logging, native Wireshark integration, GUI simplicity, and extensibility with Lua dissectors. We support COTS devices like OnePlus, Xiaomi/Poco, and Samsung, with some models requiring no root. It also supports modem-class devices like the Quectel RM50X module. The hardware requirement is limited to Qualcomm-chipset devices. On the roadmap, we plan for AI-driven fault identification, drive test visualization, expanded analytics, and dynamic signal flow graphs. Scene 24 is a transition slide. We will now move on to Section 04, the debugging scenarios. Here is an illustration of the UE registration and PDCP session procedure. Mobisync logs all RRC-level OTA messages, as well as PDCP, RLC, MAC, and L1-level messages throughout this process, and in the post-connected state. This image showcases the various stages of network attach visible from the UE's perspective, providing detailed insight into the connection process. Scenario 1 addresses when the UE won't attach. The challenge is pinpointing the failure point when a COTS phone shows no attach. Mobisync helps by providing visibility into L1/cell search updates, RRC signaling like MIB, SIB, and setup, and decrypted NAS logs for authentication and registration, allowing immediate identification of the broken link. Scenario 2 covers situations where the UE is attached but has no internet or drops connectivity. When network logs seem fine but the UE fails, Mobisync helps by exposing uplink stats like BSR and scheduling, downlink stats including BLER and MCS, and NAS PDU session logs to determine if the issue is with the UPF or N3. Scenario 3 focuses on low throughput despite the data working. Mobisync provides real-time data on RF/physical layer metrics like RSRP, RSRQ, and SNR to identify poor signal quality. It also shows MAC/scheduler details, including MCS trends and DL blur, and RLC PDCP layer stats to correlate L2 retransmissions with L1 block errors for root cause analysis. Scenario 4 involves validating UE mobility features like handover, cell reselection, and radio link failure. Mobisync tracks handover messages to detect failures, provides SIB inputs for cell reselection troubleshooting, and exposes RLF parameters and reestablishment requests for out-of-sync issues. This video shows how Mobisync 5G Logger can be the open-source 5G engineer's secret weapon, streamlining debugging for platforms like SRSRAN, OAI, Open5GS, SD Core, and Free5GC across various scenarios. We return to Scenario 1. UE won't attach. The situation is a failure to attach, even after following all setup instructions. Mobisync offers instant answers by providing L1, RRC, and NAS visibility. For the deep dive into Scenario 1, Mobisync reveals the MIB to confirm cell transmission, SIBs to check system information, and the RRC setup request for connection initiation. These are key checkpoints in the downlink and uplink process. The process continues with the RRC setup complete and registration request, including the decrypted NAS layer for core-side checks. Finally, the auth request/response and registration accept ensure a full attach, making it easy to pinpoint exactly where the process fails. This video looks at Scenario 2, where the UE is attached but connections drop or there's no internet. We investigate whether it's an uplink or downlink issue, check for DL blur issues, and examine the PDU session and UPF path. Scenario 3 focuses on low throughput, despite the network working. We look into the RF/physical layer, MAC/scheduler, and RLC PDCP-L2 layers. Mobisync exposes all three layers simultaneously to find the bottleneck. Scenario 4 explores testing and validating UE mobility features like handover, cell selection/reselection, and radio link failure or out-of-sync conditions. Mobisync correlates RF, MAC, and RLC data to pinpoint the cause of issues. Here's a quick start guide for open source 5G engineers. The 5 simple steps are: install and launch. Connect your phone via USB, select log types, click Start Logging, and then correlate and debug to find the root cause in seconds. Researchers can validate their RAN feature algorithms using Mobisync. This 4-step workflow includes capturing baseline data, deploying the new algorithm, observing live delta, and preparing publish-ready evidence. This video is about learning 5G with Mobisync Logger, taking you from textbook theory to live protocol analysis. We cover the transition from theoretical knowledge to connecting hardware and observing decoded traffic. The quick start process involves 5 steps. Install and launch the Mobisync executable, connect your COTS phone via USB, select RRC OTA, NAS, MAC plus RLC, and L1 log types, start logging, and instantly correlate and debug. Mobisync provides aha moments where theory makes sense, packet by packet, live. These moments cover the MIB to SIB to RRC setup sequence, security mode function, RAGE procedure, and real-time CSI and RSRP measurements. The newbie's 5G journey involves studying theory, plugging in hardware, starting the logger, seeing live 5G traffic, and understanding the core concepts. Mobisync helps correlate theory with real packet exchanges. Mobisync decodes all layers simultaneously, giving clear visibility into the RRC NAS, MAC RLC L2, and L1 physical layers. It shows the entire registration flow decoded end-to-end and real RF measurements, not simulations. The aha moments simplify complex concepts like the MIB to SIB to RRC setup. You can see NAS messages decrypted, understand the RAT sequence, view live RSRP RSRQ, decode UE capability, and quickly diagnose failures. This section covers the live demo walkthrough, the 5th part of this video. We will show Mobisync in action. We are now at step 5, the live demo with open source 5G RAN CN, as outlined in the video contents. The demo setup involves a host machine running Ubuntu with OAI 5G RAN and Core. The UE side device is a rooted Android phone with USB debugging enabled, connected via a single USB-C cable to the host. Here is a view of the basic 5G network setup. It shows a laptop running the host machine environment and the UE connected for logging. Next, we will review the trial license details, followed by Q&A, according to the video contents. We are currently offering a limited number of beta trial licenses for the Mobisync 5G Logger. You can contact us via email or use the provided quick links for LinkedIn and the trial form. Mobisync 5G Logger is your ultimate companion for smarter debugging and better network performance. It helps you find the right tool, right insight, and right solution. We have reached the end of the video. Thank you for watching.